So welcome students. Today we will discuss about the preparation of polymeric membranes. So polymeric membranes, basically the membranes we are using the different processes are mainly the polymeric membranes. In some of the processes we use the inorganic membranes, but in most of the processes we use the polymeric membranes. So polymeric membranes can be prepared by several different ways. So we will discuss about the different methods in this class. So first is the pressing and sintering of the polymers. So basically in this process you have the mixture of the generally this type of this process is used to prepare the composite membrane which contains the ceramic metals as well as the polymers, and generally this type of membranes has the very good mechanical strength and used for the microfiltration membrane application. So you take a mixture of the ceramic powder, metal as well as the polymeric powder as plus binder. Binder is used to bind the material and make a sheet of that material. Then that sheet is compressed by pressurized by using a compression machine, and then you have just heated the sheet below the melting temperature of the powder. So different particles will be diffused to each other, but it will not melt. So you will create the pores inside the powder. So this type of you will create a porous sheet by using the pressing and sintering method. So in this type of membrane has the irregular pore size. Irregular pore size means the pore size might be very small as well as very large. So you cannot make the homogeneous pore size by using this method. The porosity ranges from the 10% to the 40%, and main application is the microfiltration membrane. So the this by using this process you can create the asymmetric membranes also. For creating the asymmetric membrane, the heating rate from the top plate and bottom plate will be different. Then you can create the asymmetric membrane by using this process. If you heat the above plate, the top plate higher than the lower bottom plate, then the pore size of the top plate will be lower and the bottom plate will be higher. In this way you can create the asymmetric membranes. The other condition, operating condition, are the powder size. So if the particle size is large, you will create the large pores. If the particle size is small, you can create the smaller pores. Then the binding material, which type of binding material you are using, and which type of lubricant you are using. So in this way you can control the pore size and the temperature also. If you temperature is higher, the pore size will be lower. If the temperature is lower, the pore size will be higher. Okay, so this is a method to create a membrane, but the membrane has the quite irregular pore size. The pore size cannot be maintained very precisely in this process, and in fact the porosity is also very low. 10 and to 40% porosity is considered as a lower porosity. Now second process is the stretching of the polymer sheet. So this is the very simple method to create a membrane. So basically you take a polymeric sheet and stretch slowly in the all direction. So what's happened, the bonds between the different polymeric molecules will start to break down and you will create a porous structure. So in this way you can create a porous membrane. The pore size will be from 0.5 to 10 micrometer in this process, and here also the pores are very irregular in size. Why? Because the forces applied on the surface will not homogeneous all around the sheet. So you might create the small pores at the some section, you may create the large pores in the other section. As well as the porosity is in this process is higher than the sintering and pressing process. So porosity will ranges from the 60% to 70%. This process is basically used to create the membrane which is used in the medical field, especially in the burn dressing, as well as for creating the artificial blood vessel. This process is also used to create the microfiltration membrane, but the application is quite limited. So this process is basically used to create the burn dressing as well as the artificial blood vessels. The next process is the track etching process. So in the track etching process, you take a polymeric sheet and expose the sheet to a nuclear source, the nuclear radiation. So due to the presence of the nuclear radiation, the molecular bonds start to break down weak and the breakdown. So you have the breakdown the molecules between the polymeric molecules inside the sheet. Then you just leach out that material by using some type of solvent. So you will create a porous structure, polyporous sheet or polymeric sheet. So this is a membrane. The pore size will be from 0.2 to 10 micrometer in this process. And again, this process is basically used to create the membrane for burn dressing and as well as the artificial blood vessels. The limitation of this process is also in this process you cannot create a very precise pore size. The porous structure, the pore size will be ununiform, or it vary a lot based on the exposure of the nuclear radiation on the sheet. Okay, it will also vary from the across the cross section. At above the surface you have the higher pore size, the below the surface you have the lower pore size. So this is another method to create a membrane. The next and most important method is the phase inversion method or the inversion technique. So the most of the membrane used in the reverse osmosis and other processes are created by the phase inversion processes only. Okay, so this is the very simple process. In this process you make a polymer solution in a solvent. You take a polymer as well as solvent and create a homogeneous solution. The concentration of polymer ranges from the 10 to 30%. Then you just cast the that solution on a glass support. Okay, so here we are casting the solution in a glass support. The next step is the inversion of phase. So what is the meaning of inversion of phase? In inversion of phase we just remove the separate out the solvent from the polymer, so you will get a polymeric sheet. Okay, so there are different ways to inverse the phase in this process. So first is using the precipitant. So if you use the precipitant, then you can the polymers will be precipitate out and the solvent will remove. So we can use the water or you can use the other type of chemical precipitant. Suppose you are making the polyvinyl alcohol membrane. So polyvinyl alcohol is a water soluble polymer. So you take the water and mix with the polyvinyl, you take the water, you put the polyvinyl alcohol in the water, so you will create the solution of the polyvinyl alcohol. Then cast the polyvinyl alcohol membrane on a glass surface. Then use the third precipitants. Like in this process you can use the acrylonitrile or you can use the alcohol. So if you use the alcohol will remove the water from the, because water is water can be soluble in alcohol. So you just dip that whole system, the glass support which has the coated polymeric solution just in the bathtub of alcohol. So what's happened, the water will leach out from the material and you will get the solid polymeric film. So here you have the phase diagram. So here you have the solvent and polymer. This region here, this region represent the homogeneous region, this region represent the two-phase region where the polymer and water separated out. So here you have the concentration, this line represent the concentrations. So here you have the concentration, you have taken the constant concentration of polymer in solution. Once you start to increase the this line represent the concentration of mole fraction of solvent and precipitate. So just you start to increase the concentration of precipitate in this mixture, then you will go from A to B. This is the phase line where both phases are separated out. Now from B to C, once you start again the concentration, then you will come in the two-phase region where the solution, where the solvent will separate it out from the solution, or polymer will precipitate it out. So you will go from the B to C. Here you will get a pure membrane. So this is the phase inversion using the precipitant. So this process is basically used for creating the porous membranes, okay, like ultrafiltration membranes. The next method is the solvent evaporation. So you can just evaporate the solution solvent also by using the vacuum or by using the heat. So that's way you can also separate out, or you can separate out the two phases. So this diagram represent the concentration of the two phases. This is the homogeneous phase, this is again the heterogeneous phase. Here you have taken the concentration of the solvent and polymer like this point. So here the concentration of solvent is higher. Here you have this point represent the 100% solution solvent. This point present the 100% polymer. So you have taken a concentration constant mixture, you start to heat up the mixture, you just cast the film, then start to heat up the film, or you put the film in the vacuum, then the solvent will start to leach out and vaporized from the solution. So your concentration of the polymer start to increase. Here you separated out the two phases. Here the polymer will be in the solid form, as a film form, or as a membrane form, and again you will reach this point where you have the perfectly pure polymeric film. It contains some amount of solvent, but you have the solid polymeric film which can act as a membrane. So this is the second process which is used to create a phase inversion in the by using the vaporization. And in this process you can precisely control the pore size by using the rate of evaporation. In the precipitation process also you can precisely control the pore size by using the concentration, or how you increase the concentration of precipitating agent in the mixture. Okay, in this way you can increase the rate of precipitation, will control the pore size. That's why in the phase inversion method you can precisely control the pore size of the membranes. Okay, so in the evaporation, if you change the vaporization rate, then you can change the pore size. If you are vaporizing the membrane very slowly, you will get the very small pores. If you are vaporizing the solution very fast, you will get the larger pores. Okay, next method is the thermally induced phase inversion. So this is also very much applied process. So in this process we will use the concept that if you reduce the temperature, then the solubility of polymer in the solvent will reduce. So basically you heat the solution, you heat the solvent, mix the polymer, so you have the concentrated solution of the polymer at high temperature. Then you start to reduce, you cast the film at that temperature, then start to reduce the temperature. Once you start to reduce the temperature, this curve represent the phase line. So once you cross this phase line, the polymer and solvent start to separate out in the two different phases. Okay, this is the polymeric rich phase. This is above this curve you have the homogeneous phase. This is the polymeric rich phase. This is the solvent rich phase. So you have made the solution at this point, and just you reduce the temperature from here to here. So once you reduce the temperature, you will come in the two-phase region where the polymer and solvent will be separated out. So polypropylene membranes can be dissolved in this solution, toluene based solution, and can be prepared by using this process. Okay, so this process is also very useful, and you can easily control the size of the pores by controlling the reduction rate of the temperature, or the temperature you can change the temperature reduction of temperature rate. You can change the pore size of the membrane. Okay, so in this process also you can precisely control the size of the pores in the two ways. Basically, first the rate of the temperature drop, and second the concentration. If you make the high concentrated solution, you will get the non-porous membrane, or the pore size will be very small. If you have the dilute solution, the pore size will be high. So one way of controlling the pore size is by controlling the concentration of the solution, and second way is the temperature. In this case, in other previous cases also, you can control the size of pore by changing the concentration of solution. So in this way, the phase inversion method is very useful for making the precise size of pores. Okay, now comes to the asymmetric membranes. If you especially want to create the asymmetric membrane, you can create in the two different ways. Basically, the asymmetric membrane can be directly created in the phase inversion method by reducing if you have the concentrated solution and you are precisely maintaining the rate of change, if you are precisely maintaining the phase inversion method, you can create a membrane which has the larger pores at the bottom and the smaller pores at the top. So in this way you can create a symmetric membrane in the phase inversion method also. But the most recent techniques and most accurate techniques are the composite membranes, where you cast a porous membrane first, then you cast a non-porous membrane. So in this method, what we can do, we can cast a membrane, porous membrane, in at the bottom of the plate, which first make a dilute solution of the polymer and cast a membrane and dry up it very quickly, or just remove the solvent very quickly. You will create a porous structure. Then again put a concentrated solution of of that polymer on the top, or the other polymer on the top of that membrane, and then cast the membrane above it, and then inverse the phase very slowly. Then you will create a non-porous structures. In this way you can create a asymmetric membrane precisely, where you can control the pore size of the membrane very precisely, and the change of the pore size also very precisely. You can control the bottom at the support layer also, you can control the pore size, you can control the pore size at the top layer also. One more method is also there for creating the polymeric membrane, that is called the interfacial polymerization. What is the interfacial polymerization? Interfacial polymerization means you are polymerize the material at the surface or at the phase boundaries. So you create a porous membrane, this is the porous membrane, and just you polymerize the other material. The reaction occurs at the surface of the membrane. So you are polymerizing the monomer to polymer at the surface of the membrane. So in this way you can create a non-porous structure above the surface. So in this way you can create a precise thickness of the non-porous structure film on the, or the thin film on the porous structure. So in this way you can create a composite membrane, but this method is quite complicated and generally used at the lab level only. Generally an industrial level, industrial membrane or the commercial membrane processing systems, we use the solution based phase inversion only. The interfacial polymerization method only used in the lab level setups. Now the how to control the system, how to control the pores of the system. So pores can be controlled by two different ways. First by controlling the concentration, and second by controlling the precipitation rate. So if you control the precipitation rate, you can easily control. The next step is the quenching and releasing of the stresses. So once you create the porous membrane, then you have to remove the stresses which is present, which occurs or created during the which created during the membrane formation process. So just you can use the annealing process, just increase the temperature of membrane little bit, or you can use some type of quenching material to remove the stresses from the membrane. Okay, so this type of phase in the basic properties of this type of membranes, you can easily control the pore size. The pore size will be 0.01 micrometer to the 5 micrometer, or you can make the RO membrane also, ultrafiltration membrane also, nanofiltration membrane also, microfiltration membrane also. You can make any type of membrane by using this process, and pore size will be uniform and precisely controlled in this process. Okay, so there are several parameters which you can control during this process. Now one more thing about the asymmetric membranes are the support layer or the porous layer may contain the different types of pores. So either it is a finger type of pores, or either it is a sponge type of pores. This is the part of the support layer where you have the porous structure. So in the finger types of pores, you have the large area of the large pore size at the bottom, and the small pore size as the top. So it is the finger type of pores. And in sponge type of pores, you have the homogeneous porous structure, and above it you cast a non-porous membrane. So this is the sponge type structure. Sponge type of structure used in the RO process generally, and finger types are used in the other processes where you have the highly concentrated solutions. Okay, so sponge type may be also occur in the wet condition or the dry condition. So what is the basic meaning of the wet condition and dry condition? Basically, if the some of the membrane, when you kept in the dry condition, it start to crack down. These pores start to decompose in the dry condition. So you have to keep the membrane in the wet condition only. So generally in case of reverse osmosis or ultrafiltration, once you use the membrane, you have to keep the membrane in the wet condition only. So that type of system is called a wet type membranes, and sometime like in the gas separation you can keep the membrane in the dye conditions also, that is the dye condition membranes. Okay, now the different parameter which can lead to the asymmetric membrane, first is the, or which can use to control the pore size. So first is the polymer concentration of polymer in the solvent. So if the concentration is high, you will get the non-porous membrane, or the pore size will be small. If concentration is low, then you will get the larger pore size. Then you have the solvent. At the different type of solvent, you will get the different type of pore size. Then the precipitant, if you use the different type of precipitant, you may get the different type of pore size. Then the form of precipitant, or the form of temperature, rate of precipitation, so that can also use to control the pore size. Then the temperature, if you are using the temperature as a precipitant, then rate of change of temperature can also use to change the pore size of the structure. And it is also given that at the high precipitation rate you will get the finger type of a structure, and at the lower precipitation rate you will get the sponge type of structure. So basically you can control the pore size precisely in this method by either by controlling the solvent concentration of polymer, either by choosing the different type of solvent, either by choosing the different type of precipitant, either by changing the rate of precipitant, either by changing the rate of temperature change. So here you have the different type of operating parameters which you can control, or which you can manipulate to make a precise pore size of the membrane in the membrane. Okay, so this is all about the preparation method of the polymeric membrane. In general, the most important method is the asymmetric phase inversion method, which is used to make the asymmetric membrane as well as the symmetric membrane. There are other methods also which are specifically used in the medical field.